Hello viewers, welcome to today's session. In this session, we are giving this question to solve an abundant subset. So we are discussing previously how to determine the infimum and the supremum of a subset. Now here we are giving a set of questions to solve and then to show that that set is what? Bounded. How are you going to solve this one? Let's see how we are going to solve this question. So first, this is what we are going to do. We are going to define this function we see here as a certain variable. So we are going to let a certain variable represent this function. Then we solve for that variable and see whether we are going to get the infimum and then the supremum of that variable. So I'll let the function x squared plus 1 over x squared minus 2x plus 3 equal to y. Then I'll solve for the values of y. So this is what I will do. I'll multiply through by x squared minus 2x plus. So that's doing, it's a matter of what? Cross multiplication. So I'll have x squared plus 1, which is equal to y x squared minus 2x plus 3. Then I'll have x squared plus 1, which is equal to y squared minus 2xy plus 3y. So here we are going to bring all the terms to this side. That's on our left hand side here. We can also take these ones to the right hand side here, but let's bring this one to this side. I'll have s squared here, then I'll bring y s squared to here. So I'm going to get negative y s squared. Then I will take this one, which is negative 2xy up to this side, which will be positive 2xy plus 1. Then this one will come here, which will be negative 3y, which is equal to 0. Now, looking at the variable x, you can see that variable x is decreasing in terms of powers. So it started from 2 here, 1 here, and here is 0. So I'm going to factorize the variable x. That's, I'm going to make this expression or equation looks like what? Quadratic equation in terms of variable x. So here I'm going to factorize x out, which is s squared 1 minus y plus here too I'll factorize x out, which is 2yx plus, we don't have x here, so that will be 1 minus 3y is equal to 0. Now looking at this equation in terms of x, we can see it is looking like what? Quadratic equation. So what do you do? For us to solve for this one, we need to compare this one to the general quadratic equation, which is ax squared plus bx plus c is equal to 0. So we are going to compare this one to this quadratic equation. So looking at this one, you can see that our a is equal to 1 minus y, that's it, and then our b, which is equal to 2y, and our c is also equal to 1 minus 3y. And how can you solve this one? We need to think of a certain discriminant, which is b squared minus 4ac. And we have three ways of solving it when we are using discriminant. It's either equal to 0. That means when the roots are what? Real and then repeated. And then we have another one, b squared minus 4ac, which is greater than 0. That's real and distinct. And then we have last one, which is b squared minus 4ac is less than 0 when the roots are complex. Now, how are we able to determine whether the roots will be real, repeated, real, distinct, or complex? So we can determine that, but we can fix that one from the idea that x belongs to real numbers. If x belongs to real numbers, it means that there's no need for complex roots. So this implies that we are going to fuse either real, repeated, or real, distinct together. So I'm going to write b squared minus 4ac can be either greater or equal to what? 0. That means it can be real, repeated, or real, distinct. I'm going to use this discriminant to solve for the values for y. It implies I write b squared minus 4ac must be greater than or equal to 0. Since s belongs to R. Now I will do my substitution. What is b, which is 2y all squared, minus 4 times a, which is 1 minus y, and then c, 1 minus 3y, which is greater or equal to 0. Now here I will get 4y squared minus 4 out. Let me simplify this one. I'll have 1 minus 3y minus y plus 3y squared greater or equal to 0. Now this place I'll have 4y squared, and this place too I'll have negative 4 into bracket. Let me simplify here. 1 minus 4y plus 3y squared is greater or equal to 0. So let's continue. Let me clean here. We are going to have 4y squared. This 4 will multiply what's in the bracket here. So I'm going to have minus 4 plus 16y minus 12y squared is greater or equal to 0. So let's simplify the like terms here. 4 minus 12y squared, which is 4y squared minus 12y squared. I'll have negative 8y squared plus 16y minus 4 greater or equal to 0. Now here we can divide through by negative 4. So that I'll have here to be 2y squared minus 16 divided by 4 will give you negative 4y. And here will give you plus 1. Since we've divided through by negative, this sign will tend to less or equal to 0. Now here, we can solve this one using so many approaches. But let's use the quadratic formula, which is y, since the variable here is in terms of y, I will say y is equal to minus b plus or minus square root of b squared minus 4ac all over 2a. We have this one as the quadratic formula. So you can see that comparing this one to the general quadratic equation, I'll have my a, which is equal to 2 here, and then my b, which is equal to negative 4, and then my c, which is equal to 1. Now let me do substitution. I am going to have y, which is equal to negative b, which is negative 4, plus or minus square root of b squared. So what is b? Negative 4 all squared minus 4. A is 2, and then c is 1 on 2 times a, which is 2. So my y will be negative times negative 4 will give you 4 plus or minus. This means I'm going to have 4 squared will give you 16 minus 8 and 4. So I'm going to have y, which is equal to 4 plus or minus square root of 16 minus 8 will give you 8 and 4. So here I will have y is equal to 4 plus or minus, what is root 8? So root 8 will give you 2 root 2 and 4. So here we have two values for y. Y can be equal to 4 minus 2 root 2 and 4, or y is equal to 4 plus 2 root 2 on 4. So I'm going to have y, which is equal to 4 minus 2 root 2. So which can be written as 4 over 4 minus 2 on 4. And the same y, this place 2 can be written as 4 over 4 plus 2 root 2 on 4. So here I'll get y is equal to 1 minus root 2 on 2, or y is equal to 1 plus root 2 on 2. So but we said that y is either less or equal to 0. We are not using equal sign. So in short, here will be 1 minus root 2 on 2 is less or equal to y, and the same y is less or equal to 1 plus root 2 on 2. So you can see that this part is called the infimum of A, and this part is called the supremum of A. So let me come here, write it again. I'll have the infimum as the inf A is equal to 1 minus root 2 on 2, and then sup A to be equal to 1 plus root 2 on 2. So since we have the infimum and then the supremum of this set A, hence we will say that the given set A, hence set A is bounded. Thank you for watching this tutorial.